Okay, so welcome back everybody. Today will be a very short lecture because of some kind of reason. So let's just get going. So today I'm going to actually take a look at a few things. Let's just start up with okay, Unit 1B. Okay, so in Unit 1B. Of course, this is basically immediately following Unit 1A. We talked about introduction to engineering mechanics. We talked about engineering units. And then we talked about the vector analysis. So now we are going to continue on vector analysis, and then we are going to focus on something called Cartesian vectors. Cartesian vectors are the vectors in the field of Cartesian coordinate system. Okay? X and Y and Z coordinate. So problem could be 2D, could be 3D, but important starting point is, of course, very accurate sketch. If you do poor job on sketching, I guess most likely, no matter what you do from that point on, your solution may not necessarily be right. In other words, all wrong. So we are going to take a look at Cartesian vectors. Obviously, vector notation in 3D Cartesian space. Okay? And then we are going to take a look at adding, subtracting, multiplying, dividing Cartesian vectors. Then we are going to apply that Cartesian vector into two important things. One is force vectors, vectors of forces of vectors, and also position vectors. Positions also vectors. We are going to use those position and the force vector quantities to analyze certain things. Then, of course, we are going to visit dot product. Do you guys know dot product of 2 vectors or 3 vectors, 4 vectors, whatever? We are going to take a look at vector multiplication. There are 2 kinds. One is a dot product. The other one is cross product. Okay, and then each one of them comes with associated physical meaning of doing it. What does dot product mean in physical sense? If you take a dot product of 2 vectors, what kind of result you can get? Physically, what does that mean? Cross product also. Cross product comes later, probably. Okay. All right. So let's just take a look at Cartesian vectors. Next page. Let me see. Okay. So obviously, like I said, this is a 3D Cartesian XYZ coordinate. Okay. So typically, this is X and Y and Z Cartesian 3D coordinate, something called right hand. Right hand Cartesian coordinate. Why this is called right hand, anybody? Because you're using right hand, and I completely forgot. I used to do like this in statics class when I took it when I was a student. This is the right hand side X, Y, Z, which one is X, blah, 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 I forgot. You can remember one thing. Cut up like this is sums up. If this is the Z direction, this is the positive direction of X and Y. So this is X to Y roll and Z. That's what exactly says, right? X to Y, and this is Z. Now later on, this notation becomes quite important as you start talking about moments. Moments are always right-hand rule. In other words, if you apply the force to a certain distance, it creates a tendency to rotate around certain axis. What is the positive direction? Is if this is the direction of rotation, is the positive direction this way or that way? Pick up this one.
You also use right-hand rule and cross products.
Yeah, that's right. So right-hand Cartesian coordinate system is the standard. Typically for just about any statics class, including this one. Okay. So you can express your vector quantity A in X and Y and Z Cartesian coordinates x and y and z. So you are going to break down the components of vector quantity A into ax, ay, and az. So you are going to break down this vector quantity in 3D space in ax, ay, and az. So those are all three magnitudes in each three directions. If you multiply with the unit vector I and j and k, unit vectors, right? Those are the vectors with the magnitude of 1. You guys know that. So multiply by the vector in x and y and z direction each with a magnitude of 1. Multiply against the magnitude of each component of A, get you each one of those component vector of A. Okay? So this is vector A broken down into three components in three directions. This is a Cartesian vector notation. Okay? So this is a very humble beginning of it. Okay? So there are so many things you can do out of this Cartesian vector. Okay? So first of all, UA. What is this UA? Anybody? This is something called, again, the unit vector. Unit vector is, by definition, vector of magnitude of 1, isn't it? So unit vector in x direction is called I. Unit vector in y direction is called j. Unit vector in z direction is called k. But you can, of course, define the unit vector in the direction of A itself. This is called the UA. This is also another unit vector, which is very, very useful unit vector. You can find out. This is a unit vector, UA. How can you do that? You're going to pick up the vector A itself divided by the magnitude of itself A. That's going to make you a vector in the direction of A with a magnitude of 1, isn't it? That's a unit vector. So oftentimes we have to find out this unit vector UA and then multiply by the magnitude of A to represent the original vector A. Does it make sense? You can do such a thing, of course. Magnitude of the vector A can be given by each component magnitude square, add them up, take a square root. This is the magnitude of vector A. So what is the magnitude of this? This is going to be this. Each one of those magnitude, take a square, add them together, then take a square root. Okay? Of course, you know that. Also, this is something called direction cosines, quite important. So let me just indicate this. Oh, this is important because this is definitely be covered in homework assignment. Direction cosines. You're going to take the direction of the vector A and then take an angle between this direction of A against the direction of, for example, x coordinate. So this is the angle between vector A and the x coordinate called alpha. This alpha can be given by cosine of alpha is equal to ax over A. This is the magnitude of ax divided by magnitude of A itself. This is a cosine of alpha. So alpha is the inverse cosine of ratio ax over A. This is called direction cosine angles. Okay? This is important. You need this concept to solve some of the homework assignments. Okay? Let's be careful. So, this is a unit vector UA. This is the vector itself divided by magnitude of the vector A, which has the three directional components. Okay? Directional components is magnitude of ax over A. This is essentially cosine alpha. If you come to think about, yeah, that's right, isn't it? That's what it is. In other words, how much magnitude do you have? How much magnitude do you have? Angle between them is cosine of this alpha, right? So that's the meaning of direction cosines. So cosine alpha is this thing. Cosine beta is that thing. Cosine gamma is that thing, okay? If this is true, this is the magnitude of unit vector, of course. Take a square root of cosine square alpha plus cosine square beta plus cosine square gamma is equal to 1. if you take a square of each side, square of 1 is 1 anyways. So cosine square alpha plus cosine square beta plus cosine square gamma is equal to 1 anyways. Okay, so this is direction cosines. So before you go home today, I'm going to conclude a few things. In conclusion, okay, all right, 3 ways to express the vector A. Number 1, scalar components. All of a sudden, it's so quiet. So, scalar components, AX, this is the vector A's x direction component magnitude multiplied by I. This is a unit vector in x direction. This is the J, unit vector in y direction. This is a K, unit vector in z direction. This is one way of expressing vector quantity A. B, using unit vector. Using unit vector in the direction of vector A, you can say vector A is A multiplied by the unit vector UA. Okay, this is another way of expressing the vector A. Third way is direction cosines. Vector A is magnitude A times cosine of alpha I plus magnitude A cosine of beta J plus A times cosine of gamma K. So those are the 3 different ways to express the same thing. Vector quantity A. Okay? All right. So we're going to stop here today. Okay? Do you have any question? So next class Tuesday will be online remote lecture. Did you receive my invitation? Anybody who didn't receive it, please raise your hand. I hope everybody received my online invitation. Tuesday's class. So on Tuesday's class, we're gonna continue discussing Unit 1B, starting from Section 17. We're gonna solve the class example 171, 172, 173, stuff like that. Okay. So important thing, once again, let me announce once again, homework is due tomorrow 9, wasn't it? So homework is due tomorrow 9 a.m. Everybody should have restored submissions file folder. Please follow the instructions. Now, suppose if you get stuck and after you spend some time, you get stuck and want to ask a question, please send me Microsoft Teams text chat. If I'm online, I'm going to try to give you instant reply. If I'm offline, as soon as I notice, I try to reply back to you. Okay? Just email is not convenient, so please use Microsoft Teams chat text message. If you want to connect online video chat, we can do that easily. I think we did it once, okay? We connected in video chat. How was your experience? Please share. Was it good? Was it good? Okay, it was good. Good. So please do that. And then Wednesday's class, last 20 minutes, we're gonna do quiz of 1A. Please be ready for it. Any question? Have a good day. Please work hard. See you guys back tomorrow online.